So hello everyone, and welcome to the second Spotify talk of the day. So today we're going to be talking about testing at scale at Spotify and how we run fewer, smarter, and faster tests. So quick intro before we start to give you a bit of context. So we come from a part of Spotify called Client Platform. It's within the broader kind of platform mission. And we're the organization responsible for the underlying architecture, the tooling, the developer experience for our client and mobile developers at Spotify. So essentially, we're on a team called Mic Check, and Mic Check's focus is to make the testing experience good and fast. So to give you a quick outline, we're first going to start by defining what we mean by scale at Spotify, okay, and kind of give you some context on how Spotify handles testing and some of the problems we face with scaling our tests. And then we're going to focus on how we've improved our test suites by writing fewer, smarter, and faster tests. And then we'll do a little wrap-up with some key takeaways and open up the floor to questions. So Vivian, if you want to kick us off.
So when we talk about scale, this is what we mean. We have hundreds of iOS developers working across 5 different apps with about 100 PRs a day. And when developing at this kind of scale, our automated tests allow developers to ship improvements quickly and with a high level of confidence. One thing to note here, we have no dedicated QA team. So developers are expected to own the quality of their features, and these tests are the biggest signal to Spotify that the app is working as expected. When we have over 1,000 PRs a week, like Damien mentioned, this signal is super important. We have tests on all levels of the testing pyramid, as you can see here, because every team and every feature has different needs. Let's see if this works. Nice. So this diagram shows what it takes for a new line of code to get merged into the code base. Our tests are organized into 3 test suites, 2 of which are displayed here. So our most important tasks will run before any new code is introduced into the repo. If any of these tests fail, the developer is blocked from merging in their code change. Once the code is merged into master, a slightly more extensive suite of post-merge tests will start. And not pictured here, our full suite of tests run on regularly scheduled intervals on our CI machines. All of these tests run in parallel across 8 worker threads on CI. At our scale, we have 48,000 tests that run pre-merge, which means that it can take up to 30 minutes just for these tests to execute, not including building for the app for testing. So this diagram is a little bit more realistic example of our PR workflow. And this number is growing over time. Since 2019, we've almost doubled the amount of tests that we own. If we keep growing at this rate, we'll have over 100,000 tests by 2026. And this makes sense. More developers, more features means more tests. And as an individual or a member of a team, you may not think it's a big deal to add 10 to 20 new tests in a PR. But if you think about hundreds of iOS developers doing this every single day, this number can increase significantly over a year. Tests are good. It gives developers confidence that their features are working as expected.
You know, just looking at this graph, I mean, like, this number might seem excessive when we say, like, we have almost 50,000 tests running. It's a lot. But Spotify makes a lot of product decisions based on the results of experiments and like A/B testing. So at any given time, like, there may be hundreds of different experiments running across hundreds of millions of users. So we're constantly running the app in like different states, and we're also adding new features. So because it's constantly changing, we still need to move fast and kind of ship things, keep the app stable. So regression testing here becomes kind of paramount, right? So that's why it might seem excessive, but it's sort of a necessary evil, I think.
So this kind of regression testing does come at a cost. It negatively affects our PR to green time, or the time it takes for all tests to pass after opening a PR. When we have hundreds of developers having to wait 30 minutes to merge in their code, this results in hours of wasted time, resources, and money. At our scale, the pre-merge test suite has almost become community property. So if it's long or if it's flaky, all developers are upset, but they don't know who to blame. So they blame us, the test infra team. This is where we want to be. We want to be able to scale up the number of tests we run infinitely, and we want most PRs to be green in less than 10 minutes. This past year, we spent a lot of time thinking, is there a better way? How do we speed up the PR times without sacrificing the quality of the Spotify app? And the good news is, We've come to the conclusion that you don't need to sacrifice speed for quality. I know not everybody in this room is working at this kind of scale, but we believe the ideas we're going to present will be helpful to everyone who uses automated tests, which should be most people in this room. So here are the 3 ways that we've improved PR to green times and developer velocity, by running fewer, smarter, and faster tests. In the first section, we're going to discuss how we've implemented test avoidance to skip tests that aren't related to a PR change. In the smarter section, we're going to talk about test flakiness and our flakiness management system. And finally, we're going to take a look at individual test durations and how that can have a big impact on PR to green times. We're going to take the rest of the presentation to break down these problem areas and talk about our solutions to them. As per the agenda, we're going to talk about fewer first. So with that, I'll hand it over to Sami.
All right. So thank you, Vivian. So once again, yes, we have about 50,000 tests that run, and they run on every pull request. So obviously, the load on our infrastructure is pretty high, and the feedback loop is too long, right? You make a change, you want to have kind of fast, accurate feedback, so it's kind of not ideal for a good developer experience. So generally, when we think about software testing, we usually think of this, right? We think of testing the system right, and that means testing the system correctly, comprehensively, addressing all of our edge cases, having different types of tests, right? So that's all well and good. But really, in our case, with this many tests, well, we already have that covered, okay? So our concern actually becomes testing the right system. So that's what I'm going to try and talk about. Okay, so the change throughput is pretty high. We have up to 100 pull requests a day. And here's the thing, though, is most pull requests only touch 1 or 2 features or components, right? Since developers will work in their slice of the project, usually 1 or 2 features at a time. So ideally, given a pull request, only the features that change should be tested, right? So really our high-level problem here is, how do we figure this out for each and every change set? So first up, we do have some tooling that can help us figure this out, almost. Okay, so we use a tool called Bazel to build. Bazel, if you're not familiar with it, it's a fast build system. It was built at Google initially. It was used internally for years. Now it's pretty widely used in the industry. So Bazel has some nice features, like it has like good advanced local and distributed caching, things like that. But for the context of this talk, I want to focus on the dependency analysis. Okay, so basically, once we have Bazel integrated, we're able to use tools like Bazel Diff, which is an open source tool built by Tinder, I think. And it's built on top of Bazel. And basically what it does is it takes as input a diff, so a difference between 2 Git revisions, and then it outputs which nodes in your dependency graph or which targets were affected. So kind of really it should tell us, in theory, what we should test, right? So this sounds great, really, and it would be perfect if our features looked like this, right? This would be nice. A change in one feature would only require running the tests for that feature and nothing more, right? So with something like Bazel Diff, we should be able to integrate that into the Spotify repository and kind of plug it into our CI test jobs, and that's it, we're done. But, of course, things are never that simple. So what we actually have in reality is a bit different, right? Spotify is made up of all these features that can all depend on each other, and then they can also depend on shared libraries that live within the application bundle. So it makes everything very interconnected, okay? And because of the sort of nature of this, what happens is if you make a change, in any feature, well, that requires actually rebuilding and retesting everything. So this is, again, not ideal, but at our scale, it gets even worse. So let's kind of visualize what we're working with concretely here. What you're looking at here is the actual Spotify mobile dependency graph, okay? So this is everything. It's libraries and components, test targets, everything we use to kind of, require to build and test the production, App Store version, okay? So the nodes are build targets. Those are built as binaries, and the arrows are dependencies between these targets. So as you can see, yes, it's very big. It's super complex. We have thousands of build targets, thousands of internal dependencies. So why do we care about this? Well, this graph is actually what poses the biggest challenge. Okay, so this massive spider web, it makes it hard to test a singular part of the app without, again, rebuilding everything. So this is a structural problem, right? It's not because necessarily we have bad code or bad tests or we don't modularize enough, but we want targeted test execution. So if we want that, we have to kind of structure, or rather restructure our components in a way that allows Bazel diff or whatever build tooling we use to kind of compute what should be run and what should be skipped. So that's what we want to get to. So let's look at our structural solution to this structural problem, which we've called, well, it kicked off this kind of internal initiative at Spotify called test isolation. So what is test isolation? Let's come back to our mobile dependency graph here, and we're going to zoom in a little bit. So here we have just an imaginary kind of target. It has both upstream and downstream dependencies. So it depends on things, and things depend on it. So what happens if we make a change to A? Just to illustrate this, of course, we need to rebuild everything. This is what we want to avoid, right? So we end up with these kind of dependency bottlenecks where one change in a single component requires actually retraversing that entire dependency tree, right? So that's what we want to avoid. So I'll suggest something here. So if we instead split this target into two, and we kind of split the API and the actual private implementation into two different targets. So we're adding more targets. We're actually, in a way, we're expanding our graph, but we're making it like more shallow, so like wider, right? So we want to get to a point where we do a split, so it'll look something like this. So sort of inverting the dependency here. And what we end up with as a result is, well, it's a lot better because any change to the upstream, of course, will flow to the implementation. Any change to the implementation will be picked up by the build. But we don't have to rebuild the entire world, right, on the right-hand side of this graph. So we can avoid rebuilding everything that depends on the public API and only test the implementation, and that's what we call test isolation. So already with this, we're in a better spot. We can build less, we can test less, and still have the confidence that we're verifying and validating our changes correctly. So what does this look like in practice? Well, to achieve this, we've had to kind of force people to write things a certain way. Okay, so we introduced a conventional way to structure a feature at Spotify. So now every feature at Spotify follows this kind of basic template here. It has 4 different targets. Okay, so an API target, an implementation target, a test utilities target, and an actual test target where your tests will run. So we'll go through these one by one. But before I go to the next slide, kind of remember that thinking about this in the context of our dependency graph, these each become a node in our dependency graphs, right? So they're not just kind of one big ball of mud. We're now kind of splitting these, but again, keeping the graph kind of wider with less depth, less complex. So first up is your API. This should be pretty self-evident. These are going to be kind of your public protocols, set of headers that are the primary way of interacting with your components. So here's a very simple, simplistic example. The key point here, though, is that other features, again, if we're going to keep our dependency graph clean, other features should only depend on this and not its implementation. Right, so implementation, as you guessed it, these are your source files, concrete implementations of the APIs you expose. So a couple important points here. Other features should not depend directly on this. Okay, I'm going to repeat this throughout the presentation, but like the internal implementation of your feature should never depend on the internal implementation of another feature. It should only depend on its API and maybe other components' APIs that it depends on. So up next is your test utilities folder. And sometimes kind of developers complain that they have to write all these fakes, but we think this is important. So the test utilities folder will contain kind of fake or dummy implementations of the API protocols. And this is for other features to test their integration with your component. So it's kind of like the public contract for how your feature should be integration tested. Okay, so another key point here is that, again, the test utilities should not depend directly on the implementation, but rather on the API, right? We don't want, just like the implementation, we don't want this to be a bottleneck in the dependency graph. Now, as I mentioned, there are some trade-offs here. Like it is, when we write so many fakes for every part of the API, there's more code to maintain. So there's a bit more like maintenance overheads, but feature owners are kind of encouraged and in a way kind of forced to write this. But We found this to be a pretty worthwhile trade-off and like a reasonable request from developers to keep the dependency graph clean and components sort of isolatable, right? Because developers still have, I mean, we have aligned incentives here. Everybody wants faster builds, right? So it's not too hard to convince them. But finally, we have our tests. Okay, so this is what we'll actually be executing against the simulator. So this will contain all your XC test case files. These do depend, this is the one thing that will depend directly on your implementation, right? Of course, you need to be able to test the internal logic of your feature. So as you can see in this code snippet, if a component needs to test its integration with another component, it must use that component's test utilities, right? We're importing the fakes, we're not importing any other private implementations of the network or login component here. So pretty key. All right, so let's kind of rewind a little bit. Okay, so here, I mean, back to our, so this is kind of our ideal scenario, and in kind of ripping out that dependency and separating the API and the implementation. We have this in isolation. So what can we do now? We can actually do a little bit more. Now that we have this isolated, we can actually execute the tests in isolation. So what that means is, well, when we think about changing feature X, now only the tests of feature X will run. So that's good. But by default, Xcode will run your unit tests in the main app target as a host application, and then it will inject your test code at runtime. But we're able to, this is kind of generally expensive to start up the entire app. So most apps are going to do stuff at startup that isn't entirely relevant for tests. They might check for user authentication or maybe fetch like the active A/B test or something like that. So, but once a component is isolated, we can almost completely eliminate that startup overhead, right? And as you can see here, like we're able to like launch a test like several times before that first test, that Spotify test even launches, right? So, big win here. We think this is a technique, actually, again, we know like not everybody develops at our scale, but we think this is a technique that can be used really by anyone. So go ahead and like check out this article. There's many ways you can do this. Jeff Hackworth is a good kind of approach. He uses like a test-specific app delegate, so he detects when you're under test and then kind of uses a different app delegate object that launches a different app, essentially. So let's bring this all together. Well, actually, one more thing here. So we've measured this, and the impact is pretty significant. Okay, so we've been able to see like a 66% reduction in startup time in our CI jobs, and we think that's a pretty big win, I'd say.
Yeah, and another thing to note here, even if you aren't trying to optimize your CI in the same way that we are, using a test host rather than using like your normal main app host makes the local testing experience a lot faster. So I think it's really beneficial to pretty much anyone to implement this, and I've seen huge improvements just running tests locally with this change.
Okay, cool. So let's bring this all together now. So thanks to all this kind of Bazel diff, and we're also applying this uniform API-driven, protocol-driven architecture, we have seen major improvements in our build and test times. Okay, so also it might be a little small on the screen, but you'll notice that we're building a variable number of test targets and running a variable number of tests, right? So on one pull request, we might run 20 tests. On another PR, we might run 2,000 or 20,000, right? And that's the power of test isolation. So still up to now, like not all of our components are isolated. We're at about like 65%, but we can already see 50 to 80% drops in like PR to green time, and this is great for the developer experience, right? People like speed. So again, when we get this right, it means we still have a high level of confidence that we're testing the right thing, and we're testing the thing right, but we're not running all 48,000 tests. Okay, so this is kind of the structural aspect of this, addressing the complex dependency graph. And we have more targeted coverage, but it's really just half of the equation, okay? It still leaves us with individual tests that might be unstable or problematic and also slow down the feedback loop, so that's what Vivian will talk about.
Thanks. All right, so now on to the smarter section where we're going to focus on test flakiness. So another problem that we've identified is that flaky tests both reduce the speed and the quality of test suites. Imagine this scenario, we're back to our developer, opening up a PR and all tests pass except for one. The developer spent some time investigating the issue and realized it's not related to their change set. So they re-trigger the execution of the entire pre-merge test suite. All tests pass the second time around, but the developer is frustrated because they spent all this time investigating issues and waiting for CI to rebuild and rerun all of the tests. So we just doubled our PR to green time. We've mentioned flaky tests a few times already, but this is our definition of a flaky test. It's a test that either passes or fails non-deterministically, just like the example we showed above, making it seem like it's happening almost at random. Flakiness can occur for a lot of reasons, and unfortunately, some level of flakiness is almost inevitable in your test suites. We're not going to focus on why flakiness happens during this presentation. Instead, we're going to focus on how to protect developers from this kind of flaky test, a test that's unrelated to their code and slowing them down. So our solution is to identify and skip flaky tests. We've come up with a system called Master Guardian that includes 3 steps. Step 1, identify flaky test. Step 2, inform the owners of those flaky tests. And step 3, skip these flaky tests pre-merge. So if a test executes and it fails, we identify if it's actually flaky by retrying it. If it passes at least once, we consider it flaky. If the test stabilizes, say there was some sort of CI outage, the test isn't actually flaky, it was just a network issue, Master Guardian will automatically close the ticket and remove the test from the known flaky cache. While the ticket is open against a flaky test, the test is going to be skipped pre-merge, and it'll only run post-merge. Skipping tests that are flaky shortens the PR to green times in 2 ways. 1, by just skipping it, and 2, basically, we avoid having to retrigger the entire test suite due to a known flaky test. Now onto the faster section. So some tests just take too long. And based off of our test data, we consider that a test that takes 8 seconds or longer. We have 23 tests that take over 8 seconds in our pre-merge test suite. Out of 48,000 tests, this is a very small percentage. How small is that percentage, Sami?
So it's less than 1/10 of 1%, but of course these tests have like a disproportionate impact on our PR to green time, so we hate them.
Yeah. So worst case, these tests can add up to 3 minutes to our PR to green time. And currently developers have to be manually notified if their tests are too long. Normally somebody figures it out and they ping them. But we've realized that we already collect the data on test duration at the end of every test run thanks to Master Guardian. So our solution is to now identify and skip long-running tests, as well as flaky test. So Master Guardian's 3-step solution now looks like this. We identify flaky or slow test, we inform the owners, and then we skip flaky or slow test pre-merge. So now when a test executes, we check to see if it's slow. If it is, we create tickets for the owners, and we update the slow test cache. So our final flow looks like this. We check both the flaky test cache and the slow test cache before we execute any test run pre-merge. And this is what our new PR workflow looks like. Only fast and stable tests will run pre-merge, and all tests, including flaky and long-running tests, will run post-merge. This is still work in progress, but we're expecting to see big wins on our PR to green times with these changes. And if any test fails post-merge, the developer will be notified. With this new system, pre-merge becomes more of a sanity check, and post-merge is a true verification app the Spotify app is working as expected. It may seem a bit aggressive to skip certain tests if they're bad citizens, but the knowledge that their test is not running pre-merge should incentivize developers to improve their test and create a better pre-merge experience for everyone. All right, now to wrap things up. We talked a lot about Spotify custom infra. We know not all companies have dedicated teams working on this problem, and some of you may not be operating at this kind of testing scale, but here are the major ideas that we hope everyone can use to improve your own test suites and PR experience. Firstly, use a thoughtful architecture for your features. Your future selves will thank you. And look into using a test host app for your test. Even if your app is small, it's well worth it. It forces you to think about isolation earlier rather than later, and your test execution time will be much faster. Secondly, flakiness happens, but while the root cause of a flaky test is being investigated, skip it. Xcode makes this easy for you. Unblock other developers until the flakiness is addressed. And finally, come up with thresholds for test durations that work for you and your app, and stick to these thresholds. We kept mentioning 8 seconds. That's because we took a look at our own data, and we realized that anything over 8 seconds is just not worth the cost.
Okay, good summary. So course, I just want to repeat here, like being precise about which tests should run during a change. We're making things run faster, and we're doing more with less, and we're still maintaining that high bar of quality. So for us, like fast PR to green times are very important for dev productivity. We have hundreds of developers, so allowing developers really to accomplish like the most important task. They don't want to focus on the flaky CI jobs and stuff. So they want to ship new and exciting features to the users, and that's what we want to get them to. So thank you very much.
Okay, right now. So we have a bunch of questions. How do you handle the linking between the dependencies?
The linking between the dependencies, so we do have some like custom, well, Bazel does a lot of the linking for you. So, a lot of the stuff that like Xcode builds would have done, Bazel has it kind of implemented, kind of natively. And it's also really good for like incremental caching. So say it's, there's an operation, a linking operation is sort of an action that can be cached and then reused if it was done on the same commit. So this is something that we don't, there's no like fancy linking, logic that we have. A lot of that stuff is kind of delegated to Bazel.
Nice. Eric Silverberg asks, have you explored Quick and Nimble for writing BDD style tests or other testing frameworks?
Yeah, it's a good question.
Yeah,
so,
we use both. We use Nimble. It's kind of up to the developer. I think it's almost feature by feature. Some people use it, some people don't. At Spotify, we give people a lot of opportunity to write the tests in the way that they want to, and so that is something that we support, but not every feature uses it.
Yeah, and that's kind of because of our kind of modularized structure. Really, as a feature, you could decide if you want to use Nimble or use just plain old XC tests, or maybe use some other custom framework. You have to be explicit with the dependency, but we have a structure that allows like really any feature owner to use whatever framework they want. Yeah.
Okay, nice. Leo asks, have you explored or used Swift Package Manager in order to isolate features? That way, some tests can run in isolation within its own target.
We have not. I think we have considered SPM, but that was maybe a different team. And now we have our own like package management and dependency management tool that's built internally. So I think with where SPM was when we were doing this big kind of refactor and moving to a single repo, it still wasn't like mature enough for us to really consider it. So that's where we still are today.
Okay. Fernando says, great talk. Thanks. Don't you have code reviews in Spotify? Why?
Yeah, we do have code reviews
We
at
do.
Spotify. So it's not just like the test passed and you can merge in your code. So this is something that we've talked about where we're like, okay, we want our PRs to be green in less than 10 minutes, but it's not realistic that somebody's going to review and approve your PR in less than 10 minutes. And so there is a bit of a trade-off there where maybe it's not so important to get that time down, but we still want to unblock developers, and at that point, they just have to ping someone, that's on them, rather than like us being the bottleneck to shipping features fast.
Yeah, there is also kind of the constraints of like build agents, build agents that run these tests or run these jobs, and that's a limited resource, right? We get these kind of long queues in our CI jobs where like you might have to wait, for 600 builds to finish before you can run yours, and that kind of adds to the problem, right? So we want to make sure we're being kind of judicious with like what we use these build agents for, yeah.
Okay. What happens to the flaky slow test you skip? The developers prioritize solving them or just ignore it?
Yeah, so
Yeah.
we've had this system in place for flaky tests for over 4 years. So we create a Jira ticket against them, and it's kind of onto the team to address these issues. But because we ignore it pre-merge, sometimes I think that people don't prioritize fixing them. So we're hoping now that we're just going to like completely skip them, people be more incentivized.
Yes, I mean, we do try and like kind of, notify people on Slack too. We have some Slack bots that like look at, who's your team, who's your feature, and what open tickets are like, tickets are open against it. But still, I think, yeah, it's a bit like overlooked a little bit, and often it's like,
Yeah.
you know, a flaky test might not bother you most of the time, but it usually, the thing is like we try to tell people that a flaky test can also be a sign of like a real bug, a real problem in your code, right? It's kind of a code smell if something's not running deterministically. So do we always persuade every developer to work on them? No.
Yeah,
but, like,
I think it's feature by feature. Some people
Yes.
care about them more, and then some people don't.
Yes.
So every team at Spotify is a little bit different. So all we can do is let them know that it's flaky, but
yeah,
it's up to them
Damien's
to.
been pretty good with his flaky test tickets, so wherever he is.
Which Git strategy do you use? Trunk-based or Git flow?
I'm not sure with these two strategies. So we recently decided to do sort of a linear Git history. So we now don't do like big merge pull requests, merge commits. We squash everything and then merge just the one commit. But I'm not too familiar with the Git flow and Git, those two. So I hope that answers the question.
Yeah, whoever asked the question can ask you in person.
Okay, yeah, come see me and I'll show you your Git setup.
Okay, let's go through a couple more. Would you say you have a good quantity of on each section of testing pyramid, unit test, integration tests, and UI tests?
Yeah, we have a lot more. I mean, it's not like a perfect pyramid. Our unit tests are way, way more than our XUI test. So I didn't really talk too much about this, but our XUI tests, they don't run pre-merge at all. We have 10 tests that run pre-merge, and we consider those like our most business critical. Like a song will play, a user can log in. But for the most part, XUI tests will run on regularly scheduled intervals. And so it's required for every feature to have one of each, you know, well, depending on the feature, if it's not UI related.
Yeah, we also we have a program at Spotify called Test Certified for clients, and we actually measure for every feature. We measure the test distribution, and we say, well, listen, if you've got a 10 unit test, so you got 14 end-to-end tests, there's a problem here. So we have this kind of certification level where if you have a good distribution, you're certified up to a certain level, and that works. So they kind of gamifies that a little bit for developers and kind of motivates them. But I'd say that in general, I think just offhand, we have probably 600 XCUI tests that run, 10 of which run pre-merge, and that will be exactly very revenue critical user journeys. And we have 50,000 unit and integration tests. So I'd say that overall, we have a somewhat healthy distribution. Yeah.
Okay, and the last one for time's sake, what's your code coverage goal? Your code coverage.
Code coverage goal. I don't know about test. It's sort of gameable, and I feel like people can game it, right?
Yeah.
So code coverage, we do have overall. So this TC4C program that we have to certify your feature as being, kind of high quality and testable and kind of good, healthy test suites. I think we do. Wait, sorry. What was the question?
Something about code coverage?
Yes, so with code coverage, we do measure that as a criterion in the level, but it is kind of, we don't always think that it's a good signal for the quality of a feature, right? It's
for TC4C, do we have a level of code coverage that they need to be at?
I think, yes, it needs to be 80% for level 2.
Yeah.
So it is we do set the bar high, but it's not some of our, worst features have high code coverage.
Yeah,
so
it's not always a good signal of whether or not your features of high quality. But that's another team owns that, so we don't know the figures right off the top of our head.
Yeah, but I mean, we try to have good test coverage and try to get to 100%, but that's not always possible or even that relevant.
Okay. Okay, thank you so much, guys.
Thank you.
All right, thanks.